Dear students, welcome to our class on why the sky looks in different colors both during the sunrise and sunset. As far as sunrise is concerned, the first video is in front of all of us. Then I follow the explanation with three more short videos. Now, the first video is this one where you are seeing the red and yellow colors here. Why? The sky is looking yellow and red colors right now in this video. Now I explain to you. Because the sun is low on the horizon, sunlight passes through more air. Again, I repeat it. Because the sun is low on the horizon, the sunlight passes through more air at sunrise. Okay. Now, what is meant by more air? More air means more molecules to scatter the violet and blue light away from our eyes. So that's why we are not seeing in the VIBZYOR, we are seeing O and R, orange and red only. So we are not seeing the other colors because once again I repeat, more air means more molecules to scatter the violet and blue light away from our eyes. Now, so let us see in the second video. In this video, what we are saying is why now during the sunrise, okay, yellow, orange and red appeared in the previous video, and why not in this video? Just after 10 minutes of that first video, I have recorded this one. See here, now in this video you are observing as the path is long enough, all the violet and blue light scattered out of the line of our sight in the earlier slide. Again repeat, the path is long enough, all the violet and blue light scattered out of our sight in the previous video. In this video, what is happening here? The red and yellow, they disappeared. Only we are able to see blue and blue only. Now, so let us go to other video now. Here in this video, okay, the other colors continue on their way to our eyes. So that is why in the first video we have seen yellow and orange. Now, what determines the sky colors at this sunrise? What determines? Now, the colors of the sunrise result from a phenomenon called scattering. Please remember, the colors in the sunrise is because of a phenomenon called scattering. Now, molecules and small particles in the atmosphere, molecules and small particles in the atmosphere change the direction of the light rays. That's what we call it as a scattering. Change the direction of the light rays. That's what we call it as a scattering. Let us see what is happening in the next slide. Here, in this slide, you will find scattering affected the color of the light coming from the sky right now. Scattered affected, scattering affected, but the details of this particular scattering are determined by the wavelength of the light and the size of the particles. The short wavelength, blue and violet are scattered right now. Short wavelength, okay, blue and violet are scattered by molecules in the air much more than other colors of the spectrum. Now here you will see in this video the same thing. Okay, wonderful. Okay, a blue color of the sky as compared to earlier. Just 15-20 minutes back, I took that video. You know, there we have found YR, yellow and red colors. Now here, so they have disappeared, and we are able to see blue here, blue sky here. Now, so let us go to another thing, the sunset. Now, here during the sunset, what happens? Because the red has the longest wavelength of any visible light. Because red has longest wavelength of any visible light. The sun is right now appearing red when it is on the horizon. Like in the morning, with the sun is on the horizon right now on the sunset side. Okay, where it's extremely long path to the atmosphere, blocks all the colors except you are seeing red color and here and there white, yellow, light yellow color. Now, see, let's go to another video here. Here you are seeing in this video, okay, yellow and red colors. Why? Because again I repeat the same thing. Red has longest wavelength of any visible light, and the sun is red. Okay, when it is on the horizon, where it's extremely long path through the atmosphere, blocked all the colors. It has blocked all the colors. Now, so let us go to another. Okay. Uh, Video. Here also the same thing we are able to see at sunset the sun is very low in the sky right now. So that means the sunlight we see has traveled through a much thicker, longer distance in the atmosphere. Now, this is after the sunset. Now the situation is after the sunset. Now what is happening after the sunset? The shorter wavelength blue light is scattered further as the sunlight passes over a greater distance, and we see the longer wavelength yellow and red colors disappear right now. No, in the very short terms, we can conclude it like this. Why the sky looks different colors, beautiful colors both in the morning and in the evening, that is during the sunrise and sunset. It is just in one word I would like to say, light and length. Light and length. At sunrise and sunset, sunlight takes a longer path and it travels through more length in the atmosphere. This allows more blue light to be scattered and red and orange to be more visible. So this is what I would like to share with you in this class. Thanking you for your patient hearing. Here I am showing the condition of the sunset of the day. During the sunrise and sunset we have seen. Now it is after the sunset. Now the sky is slowly, okay, looking, getting darker and darker for the night.